Hello everyone, I hope you guys are doing good. So today we'll be discussing another problem of our Blind 75 series, and the problem of the day would be problem 141, linked list cycle. So given the head of the linked list, we have to determine if the linked list has a cycle in it. So the case is there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. So as we can see here, there exists a cycle as -4 over here again points to 2. And if we are stuck in this cycle, it would be a never-ending loop and we'll just keep on moving and moving and moving and moving. So we just have to recognize if there is a cycle or not. If yes, we have to return true, else we have to return false. So for this, what we'll do is we'll use two pointers, a slow pointer and a fast pointer, and we'll initialize both of them to the head of the linked list, as we can see over here. Let's consider the same example. 3 points to 2, points to 0, points to -4, and this again points to 2. So we'll have a slow pointer P1 and fast pointer P2 both at the head of the linked list. And what we'll do is we'll start traversing our list, but we'll move the slow pointer only once, but we'll move the fast pointer P2 twice. So after the first step, P2 would be here, but P1 would be here. After the next step, P2 would jump to -4 and then to 2 and would be here. And P1 would jump a single position and be here. After this, P1 would go to -4 and P2 would also come to -4. And if we reach such situation when even while a pointer P2 being faster than P1, even after P2 being faster than P1, we still reach a situation where P2 is equal to P1. That means that yes, there exists a cycle in a linked list. If there would be no cycle, we'll just run out of bounds, or the pointer P2 will just point to none. So now let's look how we would have to code this problem. So first things first, we'll initialize our slow and fast pointer as P1 and P2, and we'll initialize both of them at the head of our linked list. Then we'll say while P2 is not none and P2 dot next is not none, and also P1 is not none. What we'll do is we'll move our slow pointer P1 one position, and we'll move the fast pointer P2 by 2 positions, and then we'll just check if P1 is equal to P2. If this is the case, we'll return true, and if we run out of the loop, we'll just return false. So let's check our solution. As we can see, this is a pretty efficient solution, and I hope you guys liked the video, understood the concept. Thank you and have a nice day.